matrix template library and Bootstrap library, or I guess then what boost get, but it has to be boostified for good and bad, I guess, some years ago. And today it's going to talk about one of those influential generic libraries, Enable It, written by Bjarne and I was involved. And due to the size of the library, we needed someone else to collaborate. Howard Hinton from Networks, I think he wrote the fourth line of the library. So.
Yeah, thanks, Alvaro. So since I'm the last speaker from outside before Bjarne himself talks, I thought I'd maybe make this slightly retrospective about C++ and how it's kind of played out in my own career. I maybe tell a story about Bjarne. I apologize to everyone for not being at the banquet last night. I assume there's some Bjarne stories there, but I'll just tell one from the day I met Bjarne. I guess it was the day we met. So he had invited me and Jeremy Seek, who was a grad student at the time, to come visit, give a talk about the matrix template library that we were working on at give a talk at AT&T. And when the day was over, Bjarne and Andrew Koenig took us out to dinner at this place called, was it the Stinking Rose? Is that right? Yeah. Which, if you haven't had the pleasure of going to a restaurant called the Stinking Rose, it features garlic in everything. Lots of garlic. So we had garlic roasted chicken, and then for dessert and after, we had garlic ice cream and garlic schnapps. And I think after 3 or 4 days, I managed to actually clear it out of my system. But ever since, I know there's this relationship in my mind, it's Pavlovian somehow, between garlic and C++. And I was actually looking for, it's hard to find garlic schnapps. I was actually looking for some online and try to find one in a store. All the best I can do is find recipes on how to make your own. So maybe in the future, the next Festschrift, make some at that age for the next years. But what I want to talk about now is, I guess, my favorite little technique in C++, because in some sense it's the smallest little extension I know of. It's just, as you see, 4 lines, and that's if you deliberately add 2 character terms, it makes it 4 lines long. But yet it provides quite a bit of power to libraries that we want to use or provide certain features that C++ just in and of itself doesn't provide. Now, some of this, a lot of these techniques and our explanations and explorations in C++ came in my never-ending quest, I guess, to bring modern software practices and programming languages to the scientific computing community. When I was in grad school, did a lot of American algebra, discovered C++, discovered operator overloading, and I could write a vector class, and I could write a matrix class, and I could overload operator star, and I could write A times X, and compute a matrix vector product that way, instead of calling dgem, blah, 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 all those things. So I thought this was significant, important, spent a lot of time trying to evangelize the scientific computing community with this wonderful discovery, quote unquote, that I made. And I got a little pat on the head. He was told, that's cute, come back when you can show sufficient performance for these things. Because as we all know, Fortran has performance and C++ doesn't. So I went back, and then I discovered generic programming. I discovered the STL, and again found a system that could get all those wonderful abstractions, but now you could in fact have the performance that everyone expects. You could match Fortran performance. So again, I decided this was a significant bit of information, went out into the scientific computing community to try to this is an object-oriented program exactly, but it's C++, which supports object-oriented programming, and object-oriented programming is too slow. And on and on. So, well, I don't know. It was a slower process than I would have liked, and of course brought the famous quote by Max Planck to mind that new scientific truth is not trying to by convincing its opponents, making them see the light, but rather because its opponents eventually, well, he said die, I'll say retire. Which I guess for professors is the same thing. But because its opponents eventually die, a new generation grows up and is familiar with it. And in some ways, I'm unfortunately kind of seeing this play out in scientific community and C++ libraries. There are some of the newer departments of scientific community, new codes are being developed in C++. For instance, one of the most, I think, ambitious and significant libraries being developed right now is a library called Trilinos, led by Mike Carew at Sandia National Labs. And it really is a very modern C++ based system for doing almost every phase of scientific computing on parallel computing. So it's very nice, and I think, again, as new generations are coming along who are familiar with C++, some of these techniques and features of C++ will be adapted and embraced. And I think it just is, maybe give some props to Bjarne on all this. I mean, it's been, because it has been a long process, trying to get this language into use in the scientific computing community. I think Bjarne needs to be recognized for his continued support, advocacy, leadership for the language, and really kind of keeping a consistent and coherent view of what it should be, so that, as we are waiting for the revolution, the language will be up to speed when that happens. So anyway, so C++, as I mentioned in my abstract, I'm really thinking of C++ as not just a language, but in a lot of ways as a programming language system or an open programming language platform. It is true that it's multi-paradigm, so it supports OO, supports C systems programming, supports generic programming. But in a lot of ways, because of some of the deliberate features that were put into C++, it is also extensible in new ways. And sometimes these features or this ability to extend to C++ is called accidental. And I think that's a very unfortunate way of characterizing these things. It is true that some of these features that were developed, say by using template metaprogramming techniques, weren't originally developed as part of the template system, but the flexibility of the template system itself were deliberately designed to enable these kinds of things to be done. So I kind of bristle when people say, oh, it was an accident. It wasn't an accident. And there are systems like the Office Boost library, concept checking library, main argument library, spare parser, et cetera, that were built using some of the flexibility of C++ to create, in essence, new languages or extended versions of C++. Some of these, such as Lambda, moved from being just a library into actually being language. Concepts, well, almost became a language feature. Some more experience, I think, embedding some of the feature, some of the aspects of the feature to be performed before it moves from being library and so forth into an actual language feature. Hopefully in the next round, we'll be able to have that. So I just wanted to, again, briefly go through history of one technique This came about when we were working on second or third or fourth, some iteration of our matrix template library, and we wanted to address some concerns about performance and optimization and so forth by, in essence, encoding optimizations within the library itself, and we in fact wanted to encode optimizations within the expression template libraries we were using with matrix template library. So we would be able to write A times X, and then depending on what the type of A was, what the type of X was, what kind of access patterns it had, and so forth, the correct multiply operation would be dispatched to, or actually be generated on the fly. It would be optimal for various, depending on some of the properties that those types were. It actually turned out to be a very interesting system. It did have one difficulty that does come up sometimes with template meta programs. I think we got a 19 megabyte error message. But you have an optimizing compiler as a type, right? So if you make a mistake, so that's our current record that we know anyway for an error message. But what we want to do, as I mentioned, we want to be able to do these and do it in, or we have write optimized or optimizable operators and do it in an extensible way. We'd like to be able to introduce new types. Of course, one of the matrix template library, as the standard template library must be extensible with user types, and still have the user types able to take advantage of the operators and the optimizations. So it just using the typical expression template mechanism. If people use that, plus operator plus, and all binary operators are overloaded to create a new type. It can essentially build a parse tree at compile time, or at one time rather, and then the quality and so forth classes it and forces it to evaluate. But just the basic expression didn't provide all functionality we wanted. Of course, one could specialize expression templates for specific library classes, but again, it's not as extensible, and we run into the combinatorial explosion because we have to write specialized versions for each pair of types. We looked at the Barton enactment trick, or what's called the curiously recurring template pattern, where operators can be defined generically. Again, this wasn't quite what we wanted because it becomes intrusive in the sense that mixing different libraries together requires mixing in essentially the Barton enactment trick. So this is where a very important feature of C++ came in. So this is it's called STINI, I think is the correct pronunciation. Stands for substitution failure is not an error. And this just has to do, it's very perfectly sensible feature when one is looking through potential matches of a function, overload matches for a function. You need to try plugging in different types and generate the template, the function template, try to compile with that type substituted. But STINI means that rather than generating an error if the type and the template don't go together, they don't go together, it's just ignored. So we take that particular combination out as a candidate for an overload set. And so this among other things allows us to mix or have overloads of template functions versus with non-template functions. So we tried this idea. This seems to have been simultaneously invented in a couple of different places. Beside my group, Jaco and Jeremy Wilcock, Alkinot is also working on this, and Paul Henson and Jason Shirk had also contributed.
I think Richard Smith was one guy.
Yeah, I think he had a news group post 2003 timeframe. This is the code for enable if. So it consists of one template, or full template structure, enable if, that has two arguments, a condition and an actual type, and then it has a specialization that specializes to the case of false that has an empty body. Okay, so well, we notice that the difference between the fully general template and the specialized one is the body of the template itself just has a type def. It renames the template parameter T to type, and then in the specialized false case, we don't have that missing type number. So that's actually the SINI condition. So we have substitution failure on false.
Quick question? Yep. Just to clarify, those are the 4 lines of code you mentioned earlier?
Those are the 4 lines. And yeah, it seems very, okay, not remarkable. Let's see what we can do. Well, so if you use enable if in a function template signature, either as an extra argument that the function wouldn't have, or as part of the return type. So in the first case of F, function template is templated on T, and now we use enable if and check to make sure that this type T has a certain trait. If it does not have that trait, that value will go to false. We get the second definition of enable if. Right? So and then the SINI will fail because there's no type def there, and then that function will be taken out of the possible overload set. So, and then another way we would get is again put enable if in the argument list and give it a default value. But typically, I think in most use cases I've seen it is with the return time. So some you can use it with classes as well. We want a certain class to be present or not. So then it goes out of for class template partialization, specialization. So another, or one feature, I guess, of this being able to pull functions in and out under user control, in and out of the overload set, is you can overload or specialize functions without having to do the tag dispatching that we've seen. So in STL, for instance, this is the advanced function. It's actually specialized depending on if you have a random access iterator. Right? You can advance in order one time, in constant time, from where your iterator is to where you want to go, just by adding in to the iterator. For iterators that aren't random access, you have to go through a loop and add or increment the iterator one at a time. So it's important to be able to do that specialization for random access iterators. The way the specialization is done in the STL is each iterator has a tag, trace mechanism, accesses that, and then there is another function, underscore advance, has the tag as the third argument, and has overloaded that, and so the compiler will dispatch to the appropriate one with the function enabler version of the enable if version of dispatching. We can instead enable advance. You know, we don't need this underscore advance. We can just call the random access version or the non-random access Now the enable if, or this technique, in some sense, is more than just, it seems like a simple trick, right? So we have this whole line, you can put functions in and out of the overload set. In some sense, this is what I meant when talking about C++ being an extensible programming language platform, right? There's pieces of the compiler functionality of the overload resolution mechanisms that can be manipulated by source code programs. And there are other places where similar kind of things can be done with C++. This gives us the ability, sometimes, to extend and build the compiler to try out new features without having to be compiler hackers. And it lets one do it across different types of compilers, or different vendor compilers. So one of the features, of course, we've been interested in for some time is concepts, and I discussed those previously in his talk. So let's go through some of these. In some senses, like I mentioned, a concept is defined by a set of properties that a type might have. But with enable if, in some sense, we are able to invoke functions or not based on whether certain properties appear in the type that we pass into enable if. So in other words, we can overload functions, if you like, based on concepts rather than one particular type. So we can do concept-based overload, if you like. So this example, we have a print function, and we want to have it work for show types that model the showable concept. So not just particular types, but an entire class of types. And so using enable if, we have a traits class that determines whether a particular type conforms to the showable concept or not. And if it does, we invoke this particular version of print. And we can do other types of specializations with enable if. This example just shows one way of ameliorating some of the benefits or some unexpected behavior, let's say, of argument-dependent lookup. So if we want to make sure a specific version of spot in a particular namespace is called, and we can use enable if to make sure we dispatch that one rather than having to run across as we're going through the overload sets as determined by ADO. So anyway, this quick tour through some of the benefits of this particular small feature. The feature itself became a component in Boost, and I saw at least one code snippet that had std : enable if. So
I was very close.
Yeah, it's in C++ a lot.
okay, so it is actually part of the language, in fact. There's some labels as well. So conclusions, again, C++, I really consider it, it's been very important, as I mentioned in my own career, to be able to use some of this flexibility and power. I thank Bjarne sincerely for developing and advocating, continue to hold together this language and this community. Besides the simple thing of there's 4 different kinds of features that can be and have been prototyped and used in C++ libraries and then moved to language features. And so I think this and some of many of its other features will continue to keep C++ as a relevant and important language. And then my final conclusion is be prepared if Bjarne chooses a restaurant.
Can you go back to the slide where you showed the advanced course done with the enable it? The issues on it. And it was remarkably neat and fun when you first get it, and then you use it in far too many places, and now trying to figure out when it's appropriate to use. So I come to something like this, and I wonder, how do I document this for the end user? I don't want to document it in the enable it form, because that's a lot of noise about the signature that the user doesn't need to see. But that's what it is in the header file. How am I documenting what is the actual advanced function that the user should be thinking about?
That's a good point. So I think in that case, just template class iterator, class gist, and advanced, kind of hide the as far as what the user seeing.
So one thing I wonder, with enable if becoming so popular and the ugliness of the syntax, the fact that you often have to be clever of how to use it. In fact, it's really hard if there's not a return type to do it right. So what should the syntax be? We have this discussion about the static if or stuff that I'm doing and resolving, which basically embeds the enable if technology in what looks like a concept. Random iterator, IC, expand to that inside the compiler. We have been thoughts about how to get just the right semantics and some syntax that people can live with. This stuff's great, but it's hard to scale to meanings.
Right. Well, I thought 4 lines, if it's obscure, it's easy to understand. True. No, I think as you mentioned, I think those things are still under discussion with static if. Might be more promising. At least it makes the syntax a little less, or a little more familiar.
Okay. This, I guess, if people are willing to sprinkle these kind of things all over the standard library and elsewhere, it's a sign of we really want concept.
I think that's what it is.
So, I actually think these last 2 talks go together because I don't think you can reasonably say just ignore the enable if clauses when you're documenting this because the pragmatic effects of what kind of iterator you have, or even if you have an iterator, is important in how you use this type. So they don't have to see the syntax in the documentation, but they do have to know that being an iterator is required, and being a random access iterator changes the complexity.
Yeah. Well, again, this is the documented, just having in this particular case, having concepts, and you could make that part of the interface of the document. In the right way.
My brief way of saying this is your order will be on concepts. And the concept is expressed as predicates, and the mechanism of using happens to be enable if. We have to get back and actually talk about what it really is, rather than the implementation of it. But I think for the documentation, you can do exactly the first thing. This is order we're going to be policies iterator.
Fun little anecdote. I was looking at argument, some old emails from argument at the time we were working on this. So he was very happy after working on the MetroWorks library and applied enable it to deal with some of the peculiarities of the type parsings in C++, and he had to implement the sign and cosine and hand functions and so forth. And he described a case where he managed to call us 730 overloads in 2000 overload set that you haven't yet implemented, 2000 function overload set to get all the conversions right. Now, well, that's, for that, we have just given up, but now we will do that in a few functions.
And there's one more question, which is the other problem I've had with enable it is if I've got a reasonably large overload set, I've got these enable ifs in there, and for some reason I'm no longer matching any one of those functions. Before I used to get, if I match a function, I'd get a nice error to tell me, okay, I've got to translate this half page, 3 page error whatever to figure out why my type's not working quite right. If all I've got is an ambiguity, because I didn't match any of them, then if I was, sorry, if I was saying, here's a bunch of close things, I'm finding it's very hard to actually figure out why I didn't get the function I thought I was going to get. If you had any luck in helping to figure a way through these kinds of diagnostics, or is that still very much a research project or a towards concept?
I think that's definitely going to the context in our work.
I guess I'm going to do last resort, function that matches just the last resort. Just talk about that. Is Yuri going to do that? Yeah.
Usually like what, I use a lot of language and I like it for, and usually it's very good when the condition is kind of orthogonal to everything else. But like once you have an overload set where you have multiple conditions, you have to like pay attention that you always get exactly one coming out. Do you have any thought about how to improve it so that that's where I start to prefer overload resolution because it doesn't have that problem. It usually chooses one, right? Maybe sort of can enable it to be like generalized or whatever the reincarnation of enabling will be the concept to avoid that problem that the conditions have to be exclusive.
Well, so sometimes we are recommended that a disabled def, right? So that you can take things out to reduce ambiguity, or I guess we could have an enable if and only if. At least kind of standing close particular techniques for resolving the ambiguity. Again, hopefully as concepts continue to be developed, those kinds of things that we can and provide the right kinds of error messages to inflate that.
Yeah.
My guess is it will be absorbed or subsumed into concepts. When we figure out how to make concepts simple enough, because what killed the previous concept was they were too complicated. We need something notationally, conceptually, that's simpler than this. This is wonderful, but it's notationally too difficult to teach people, and as people says, the error conditions are hard to diagnose, and it is likely that absorbing into a language feature will remove the error messages. We can specify precisely what happens if we are doing an order with our concepts, or what happens when we don't need it. Whereas since this is a workaround, it's a perfect workaround, it's essential for C++ 11, we've used it for almost 15 years. But I think we're almost there when we know how to do it better. Half the experience with this.
Last one.
I say one thing. Since I asked a couple of negative questions, and I will say I love this. It's very, when you need it, you really need it. And one of the benefits of C++ 11 is we can now have default function template arguments. So you can use this in constructors in C++ 11 that was a big problem in C++ 03. So